Good afternoon, everyone. Dear participant, sir has already joined. Kindly switch on your videos. Akshita, are you there?
Yes, ma'am, I'm ready.
Good afternoon, sir. Welcome to the afternoon session on our 1-week professional development program on applied AI and expert systems, sir. Akshita, over to you.
Yes, thank you. A very warm welcome to everyone joining the afternoon session on the professional development program on applied artificial intelligence and expert system. Joining us now is Dr. Atul Negi. Dr. Atul Negi is a professor at School of Computer and Information Sciences, University of Hyderabad, India, and previously worked as director at PIES Indore. He holds the PhD and MSc degrees from University of Hyderabad and IISc Bangalore, India, respectively. He graduated with distinction in Electronics and Communication Engineering from Osmania University, Hyderabad. He is a senior member of IEEE and serves as a volunteer in IEEE Hyderabad section and was a chairman IEEE Hyderabad section and is presently the vice chair technical activities. He is a technical committee member of IEEE SMC in soft computing division. He has authored more than 100 publications in peer review conferences and journals. He is an associate editor for Springer Nature Computer Science Journal and serves as a reviewer for various IEEE transactions and international journals like Pattern Recognition, Information Sciences, and Neurocomputing, etc. He has worked as co-investigator on the Indian Language Resource Center, Telugu, sponsored research projects from DIT, Government of India, principal investigator for Robust OCR project DIT. He was also awarded the IEEE Region 10 Outstanding Volunteer Award in 2020. Thank you for joining us, sir, today. We are truly to have you with us.
Thank you. Thank you. I'm audible, isn't it?
Yes, sir, you're on.
Fine. Okay. Thank you for the invitation. Dr. Padmaja has asked me to speak on some topics related to AI. There are simply too many things to show. Perhaps I will start first by sharing my screen. So I'm sharing my screen. So if I share desktop, I think so everything will be visible. Whatever I show on the desktop will be visible. So I suppose that should be visible now, right?
Yes, sir.
Okay. Let me switch to the browser. Okay, so I suppose you are able to see the site which I have opened. I think I can minimize this thing also. That is. Okay, so I have successfully been able to hide the meeting controls. So anyway, now what I'm showing you is like, see, we are studying AI, and we must know and understand that what is the complete course which is there related to AI. I think that kind of approach is what is given in that schedule which is given to everyone. So if you see this site, which is from the one of the very famous universities, that is the Penn State University, and there they have this course on the principles of AI, and they are having some week-wise kind of the readings, etc. are there, So this is to give you an idea that what is required to be learned in a complete course on AI. Okay, that is the first thing which I wanted everyone to note. Okay, what I should do is that let me copy this link, and I will see how to paste this link into the chat. So I'm pasting this link into the chat. I hope everyone can see that. If there is any difficulty in seeing this link, please let me know.
Yes, sir. Chat is visible, sir.
Okay, thank you.
Link is visible.
Right. So that is one of the things. Then let us see one more thing. So one more thing, which is that okay. So amongst the other things is that there is the okay. Let me switch to another thing, which is this is the book actually. I will zoom this to show the width. Okay, so this should be visible.
Yes, sir.
Yeah, so this is actually the important this is the important textbook, which is the standard textbook worldwide. This is the standard textbook, which is called as AI modern approach. Okay, everywhere people are studying this approach. That's in Norway AI modern approach. Okay, so any study into AI, that too, although a new edition has come, fourth edition has come, it is not yet available in India, or this the PDF version is not available. Fourth edition has just been launched. Okay, there's not so much different in the fourth edition. Some things has been updated. Okay, but as you can see here, let me show the table of contents. So when we are studying AI, the comprehensive view is very much required. Okay, so that's why the table of contents is important to be studied. And now let me say that anything which you want to learn, we can also look at this website which is there, aima.cs.berkeley.edu. This is a website, and it is really a very important website. Where is yeah, just look, please look at this. aima.cs.berkeley.edu is the website for this book. And updates and other things should be also be over there. Okay, and if we go further, so this is the contents. And today what is my part is that see, it is all everything is connected. That's why I'm trying to show that in the entire table of contents. So you start, the entire concept is that unless we study this intelligent agent, okay, whatever we are going to explain, it is in the context of intelligent agent. Okay, so I cannot go into that because I suppose somebody else has gone into that, those kind of things in this schedule. So then how does a intelligent agent work? And it is, the problem solving manners are shown, that is search approaches are shown, the different types of search, and working with the constraints and knowledge. Then comes this part that if a intelligent agent should work, it should have a reasoning. It should be able to represent knowledge, and it should have reasoning. Okay, so in this book, this chapters 7, 8, 9, and 10, including 11 and 12. So these are, this part of the book is devoted entirely to the knowledge representation and reasoning and also planning, because planning is defined that how you are using the knowledge and applying it for the reasoning. Okay, so that is how planning is done. Planning involves the time, schedules, resources, and things like that. Then one part which is very important is this part regarding the knowledge representation. And here you can see important word which is uses ontological engineering. I'll try to take up some aspect of this, because we are now building big structured representations of knowledge. The big structured representations of knowledge is it's called as the ontological engineering. For example, let us say that if you are studying smart cities, so what is a smart city? Under a smart city, what is a there? If you go into that, there is a block in a smart city block. What all should be there, and like that, it is a structured representation of the information regarding a smart city. Or say like let's say automobile. If you say automobile, under the automobile, what all are the assemblies, sub-assemblies, sub-assemblies, like that. That is a very structured representation of the knowledge and information. So if I have to debug any problem which is there with respect to an automobile, then I have to be able to look at the ontology and then be able to understand which parts are there, what kind of malfunctions could be there, and from that being able to come up with any solution model. So that's why these ontological representations are very important. As many of you are from computer science field, then if you have studied this object-oriented design, object-oriented programming, there also we are having this structured representations of knowledge, which is in terms of this class hierarchy and structure. Okay, so many principles also from there apply. In addition to that, some concepts from databases and things like that are also applied. Okay, so that is, so this is the scope. This is the scope of the things which we are going to look at. All right, so and we can be very interactive in this program. At this stage also, if anyone is liking to ask me some question, we can look at that. Okay. Yeah, so if anybody is trying to ask question also, it's okay. Please feel free, you can ask me the question. Hello, am I connected?
Yes, sir.
Yeah, okay. Okay, yeah, quickly we can take a few questions on the scope of the things which we are trying to study, and then we can get on to and do something else. So okay, and if there is no clarification, maybe then we can go ahead.
Most of these participants are new to the subject, sir.
Okay. So
and the students are learning first time this subject, this semester.
Okay. So that's why I think so. Then it is very important that they will understand like what I have been showing. That is these resources which I have shown. This textbook and table of contents resource. So if they study the table of contents of the textbook, and we start that what is the AI, what is the foundations of the AI, what is an intelligent agent, like that, problem solving and all that. So you must understand and try to understand in the sequence. Okay, so that's very important for the new learners. Okay, and some websites like this are also giving that. Suppose if I have to learn what all I should learn, which are the lecture slides, which are the history of AI in robotics, how it is connected. So some very interesting links are also given here. Okay, so like the subjects and things like that are also given here. For example, if you read this site, maybe it's difficult for people to see that. Let me just see if I can. I'm zooming it in further here. So this is the same website, the link for which I have shared. Okay, and this is a study guide, and this is giving very lots of interesting links, which is there for people to read and get some more insights into AI. So this part is some of the algorithmic parts or problem solving parts. Okay, now next part is about this hill climbing search, genetic algorithms. Okay, then this is about problem solving as constraint satisfaction. So in problem solving and reasoning is an approach to solve the problems. Okay, and then there's this part, that is this part which is about the knowledge representation part, that is logic agents with the explicit knowledge representation. And here different aspects are there. Say that I represent the knowledge in terms of logic. Okay, propositions in the logic, that is why it is called as propositional logic. Then propositional logic as a so basically knowledge representation requires a language. In a language there is a syntax and semantics. Okay? Syntax means that how the sentences in the language are built up, and the semantics is that what is the meaning associated with those sentences of the language. Okay, so like this, the propositional logic as a knowledge representation approach is presented. Then you are having the models and logical notions of the truth and falsehood. So suppose I have built up a knowledge representation. Then how do I go through the entire set of statements in that knowledge representation? If I have a question, then how do I try to answer that question? Okay, is this true or false? Suppose. So for that, then you have these inference rules. So modus ponens is it's a Latin name in which it says that how to reason. Okay, so that's modus ponens is giving us that how we should reason, and so it is a sound approach. Okay, but there are problems in that, because completeness is an important aspect in computer science. So whether it is complete or not, that will be an issue. Okay, how do you extend the modus ponens? That is a resolution. And so like this, that is it possible to have a logical agent which is not having the explicit representation? Because it is always not possible to have explicit representations. In real world, we hardly deal with anything which is an explicit representation. Mostly it is implicit only. All the real world systems, like systems, or even rather the human beings, we are working a lot on the applied in implied kind of information. Rarely is it that we are going in for explicit kind of representation, explicit kind of statements. Then we are having first order predicate logic, which is the extension from the propositional logic. Okay, now there are some generalizations which are technical aspects which are there from the propositional logic, which is more general. Okay, and then using that we can think of ontological and epistemological approaches. That is, ontology is like dealing with a structured representation of knowledge. Epistemology is related to the meanings behind the knowledge. Okay, so then the syntax and semantics of the first order predicate logic is there, and then theorem proving is for the reasoning in the first order logic. So there you have the operations, that is unification operation, instantiation operation, and entailment things are also there in this. Okay, so as you can see here, as I was trying to show you, chapter 7 from the AI modern approach, that's the thing which I was shown. Okay, so like this, these are some links and all that which can be explored. Okay, so that is all possible using the link which I have given. So from the link which I have given, all these things further can be known about. All right. So further, what we can do is that maybe I will then start and switch over to the presentations which I have collected. As there is all lot of, mostly it is all textbook material and all that. I have not tried to make any other original slide of my own. Okay, because this is all applicable. I mean, it's all well known, and Okay. So as is introduced, I work at the University of Hyderabad in the School of Computer and Information Sciences. Now, the interesting thing is that this department of ours has been offering an MTech in artificial intelligence from 1988 onwards. Okay, so in Hyderabad, at least, this is one of the places which is very long established in terms of the courses in AI is concerned. Okay, and a lot of our faculty, very large number of faculty, is all dealing with this AI course and things like that. Their qualifications, everything is from that. Okay, so this is Imperial College London is an important place to understand because a lot of developments in logic as an AI and knowledge representation has taken place from this institute. Okay, so this is where from some course which is there, I'm just bringing you the course slides which is there. Hopefully that will be useful for us. Okay, so first question which we start with is that what is representation, or rather about the representation. Okay, so as I explained earlier that we are having an AI agent. AI agent is a independent entity who is trying to solve a problem, which is trying to deal with the environment, and it is the environment may be changing, and the information about the environment may be incomplete also. So many difficulties will be there with an AI agent. Okay, but what we have to do is that we have to be able to represent the environment which the agent is going to be acting in, and propagate that its knowledge which we that way the AI agent is acting. Okay, so then there are some things which we have to have with respect to that agent. First thing is a fact. Okay, we need to have fact. So that is that we have to believe in certain things, and something which we are observing about our environment, that has to be represented, and it should be available for the agent. Okay, to be able to reason. Okay, next thing is that the procedures. So what is a procedure? Procedure is going to act upon the knowledge which is there, and it may add further knowledge into the set of knowledge which is available. Okay, and next last one is that related to the interpretation and actions related to that knowledge, and how do we relate with respect to that knowledge, and how it is affecting our definitions or vocabulary and things like that. Okay, so that is the interaction of agents with the knowledge. Next thing is that that the correct type of representation is very crucial, and because the correct representation is giving us a lot of power. Okay, so as you all know, there is a difference in the representation, that every computer system is dealing with information in a binary manner. Human beings are dealing with information at a different level. In NLP and all that, we are trying to bridge the gap between these two representations, so that the human computer interaction becomes much more easier. Okay, so this gap between the computing systems and human interaction, this was observed long back. Okay, it was observed as soon as AI has started, like in the late 50s itself, people have realized that and then started working on that direction. So this was the early realization in AI, and it was also understood that if we choose the wrong representation, then we will not able to work successfully and solve any problems. So the wrong choice would then can be bad, and it can lead to the project failures and things like that. So as it is such a crucial area, the active representation research is continuing on this. Okay, so that's about the representation. Now, what happens next is that we want to choose some type of representation. Okay, why is choice of representation so important? Let me give an example. Okay, suppose I give you a large 4-digit number. Okay, so like let's say 10,024. Suppose I give you that number and I ask you that find me the square of 10,024. Okay, so you all know a multiplication process and all that, and you will quickly be able to find out what is the square of the 10,024. Okay, so you are able to solve this problem of finding the square of 10,024. Now let me make the problem a bit difficult by saying that the 10,024, first you represent it in Roman numerals. You represent 10,024 in Roman numerals, and then using the rules for manipulation of the Roman numerals, you find the square of the 10,024. Okay, how many here will be able to do that? Okay, any feedback on that? Is anyone confident in finding the square of 10,024 using the Roman numerals? If somebody is confident with that, please let me know. I sincerely doubt that somebody will be able to find the square of 10,024 which is written in Roman numerals. Okay. Any comment or question on that aspect? Looks like,
Students, you can use chat box.
yes, please. Yeah, this is very important for me because having feedback is good, because I think this example of this one is very important, because if you understand the difficulty that of how you are multiplying in the Roman, if you are able to understand that difficulty, then you will really understand that what is the power of the knowledge representation. Um, I'm just trying to find the Zoom controls somehow. Yeah, I hope I can find the Zoom controls. So okay, yeah, I managed to find that. There is absolutely no message in the chat box, is it? Okay, no problem.
I think nobody is able to answer, sir.
It's okay. That's okay. But if you have some engagement with the people who are there, you can sort of give them some assignment and say that how will they work out that how to find 1024. I mean 10,024. How do you find the square using the Roman numerals? Okay, so then once somebody tries to do that, then you will understand and appreciate that the representation of numbers in our decimal number system, how important it is. Okay, and how easily we are able to compute and find the answer to simple arithmetic problems. So if once we are convinced that representation, the choice of representation is very significant. Okay, so I hope with this example, I have been able to convincingly prove that the choice of representation is very important. All right. So progress in AI is also very much related to the choice of the representation, the manner of representation. Okay, so whether there is a best representation, that we can say. Okay, so this is the problem here, that is the right representation is crucial, and finding right representations is being done all the time. It is an active research area even now. Okay, then how do we choose that representation? Okay, so that is related to the reasoning process. Okay, so after all, we look at everything in a package deal. It is knowledge representation and reasoning. Okay, so as I have shown you in the beginning, that FOPL and those kind of things, that is knowledge representation and reasoning. All right. So not only that you are going to choose the representation, you should also know that what is the approach of reasoning in that, within that representation, and that is the thing. Okay. Sometimes in the past, people have used this programming language, like which is called as Prolog and Lisp. Lisp kind of thing is very general purpose, and but it is not necessarily tied with logic. But this Prolog is there. Prolog is highly structured language, which is very much tied up with the logic. Okay, so in fact, unless we know logic properly, we cannot understand or write the programs in Prolog easily. Okay, so only if we know the logic and all that, we'll be able to write the programs in Prolog. So but being an AI student, one has to know some programming language which is related to AI. Many things are there possible, people are doing with Python also, but many things which are there in Prolog are very convenient and quite useful to know and apply. Okay, so now the thing is that about choosing a representation. So first order theorem proving is that is first order logic. Okay, so first order logic is there, and sorry. So first order logic is the first step in the representation, and then we can even have neural networks. Okay, so actually right now a lot of research is going on in which they want to tie up the machine learning and training which can be done in neural networks along with the logic which is there in the present systems. Okay, so like that, these kind of things, applications and all that is going on. And if we see this, so if we see this, we can see that there are these general representations, which is in the form of logical representations. Another kind of thing which is called as production rules. Okay, why is it called production rules? Is that because of knowing one rule, we can apply that rule, and that may produce a different situation in the logic, in the representation, from which we may get another rule where to apply. Like that, it is a production system, meaning that you will be able to go from one of the rules to the next rule to the next applicable rule, and you will search which is the application rule, and you'll search for that rule, apply that rule, and then that will be leading us to some kind of inference and logic, and that is going to lead us to some kind of action or behavior also. Okay, so that's the idea of the production rules. Next is about semantic networks. So conceptual graphs and frames. This is the most common things which is there, conceptual graphs and frames. A lot of AI systems have already been built using these two things, that is conceptual graphs. So a researcher by name of SOWA, SOWA, and he is very much related to the idea of the conceptual graphs. And as you will see later on, the conceptual graphs, etc., are quite easy to understand. Only thing is that the link through the attribute is the important thing, and how we represent that and access that and reason with that. That is the main thing to know, to learn and understand. Next thing is about frames. So how do you formulate a frame? What all should you keep in that frame? What link should be there in the frame? And other things, that when is the frame going to be active and things like that. We are going to do that. Then further on, you have so many things which is there, the types of statements which are there in real life. How do we represent that and things like that? So ongoing research, description logics kind of thing is there, which is maybe a lot of research still going on there. Okay, let me change the slide. Okay, so the next thing is that in a with respect to then next thing which we should read and try to understand is that what does it mean by logic? Okay, so is there only, so sometimes when we are arguing and all that, we don't like what other person is saying and we question their logic. Okay, we say that what type of logic is that? So this is also indicating that there can be so many different types of logic. Okay, so there is some logic which is there with different people. Okay, and sometimes in a joking manner, somebody also they say that there is something which is called as this type of logic or that type of logic. Some kind of name is being used to that, and they say that if you can't explain something to somebody else, that we don't understand their logic. So what it means is that uh, the basis of representation and reasoning is the logics, and there can be not just one, there can be so many different types of logic. Okay, now imagine that the agents are there, one agent has to cooperate and interact with another agent. Okay, so then what happens? The best way to get across this problem is that you have to have a standardization. Okay, so standardization has to take place with respect to the language, and you have to have a language with the rules. Okay, so why is it that is required? That the representation should be strong and it should be unambiguous. Okay, specifically what we should be done should be specified in the rules, and also for the engagement of others. This rules, having the rules clearly is very important. So what we want to do, we want to avoid the ambiguity in the representation. Okay, there could be other errors, but we want to reduce the ambiguity as far as possible. Then other thing is that we want the communication of information from one agent to another agent be in unambiguous manner. Okay, what is this word unambiguous? Means that there is only one way to interpret it. Okay, so uh, if there is only one way to interpret it, then no, we are more understanding what is going to be the outcome of some object behavior. Okay, so for example, that suppose I have to give some sweet packet to the that is, suppose I have to give, it's a birthday, I have to give a sweet packet to the teacher. All right, so there is a very clear thing that okay, that sweet packet is there, it is for the teacher, like this. That is an unambiguous approach. And in English though, uh, we are relying so much on implicit information, and having such kind of concrete rules for the language is very difficult. Then another thing is that we should be able to move between the statements in the language, or if we have different representations, we should be able to export and import the different information statements from one set of logical representations into another. Meaning, this is the second point here. The statement can be represented in different logics, okay, and perhaps differently in the same logic. That is also true, because even in our general language and talking, we will say that in other words. Okay, so means that we are trying to get our statement across clearly, and to help the other party to understand, we are trying to state the same information in a different manner. So that's why we alert them that we are going to say the same thing but in a different manner, and hopefully you can understand that. So that's why we say use the term in other words. Now, what are the statements which are there in the language, and how much they can carry meaning? That is called as the expressiveness of the logic, which is this third point over here. How much can we say in this language? Okay, that is a bottom line, that and sometimes it is that say for example, a student is writing an exam. All right, the student is writing the exam, and the question is there. Same question is also given to other students, but one student will write, they are writing to the point, they are writing all the points, necessary points, okay, and their expressiveness is much more. They are having clarity, good handwriting, everything, they will get more marks. But one other student may complain to the teacher, sir or madam, that I have written some 10 pages, but still you have not given me the full marks. Okay, so which means that if you are requiring to express something which can be expressed in 5 pages and you're requiring 10 pages for it, that your expressiveness is poor. Because if your expressiveness was good, then we will be able to say the same thing in less number of pages, correct? So similarly, like that, if you are having a language or a logic, the logic which we are having, the expressiveness of that logic should be very high, that we need not make too many extraneous and other types of statements. Okay, so that is the expressiveness factor of the knowledge representation. And we should not confuse that with the logical reasoning, meaning, okay, reasoning is a different thing, representation is different thing, like that, no? So, but the reasoning process is having something common with the logic. That much also we should not forget. Okay, so reasoning is a process. So always we say knowledge representation and reasoning. Okay, why is that? Because I may express so many facts, and I can just store those facts. Okay, but what is the use unless I know how to be able to retrieve it, I know how to be able to take any inference from that and then act upon that inference. So that's why that the reasoning and representation have to go together. All right, we go on to the next slide then. So which is about the syntax and the semantics. Okay, syntax and semantics, if you are somebody has studied compiler design and things like that, okay, they will know that this kind of terminology is also used there, right? Maybe if not the students, maybe the faculty members or the professionals who are attending would be remembering that the syntax and semantics is there. So similarly, for knowledge representation and logics and all that, we also have this syntax and semantics. And the syntax and semantics is such that we are having the rules for constructing the proper statements in that logic. Okay, that is then written here as legal sentences. Okay, but in real life we don't always express ourselves in the perfect grammar. But for the formal logic systems, unless the formula is well formed, Okay, further on, whoever has studied logic and all that, you are always looking at well-formed formulas. Okay, so first, any information which you have to express, you have to form it as a well-formed formula, and then only the interpretations and the reasoning, etc., will take place. Okay. However, in real life, we use broken type of language, but still we are able to carry the idea. We may say, like, for example, in PowerPoint. In PowerPoint, I never write complete sentences. I write only points, right? So that is the thing, that that human beings are able to convey the meaning, even though the syntax is not followed so correct. Okay, so that is the great thing. And in the syntax aspect, what we have to understand is that what is meant, the rules which are there. Okay, so for example, in English, you are having spelling rules. Okay, the letters are important, and whether you give comma or full stop, that also matters a lot. Okay, I like to use the one example, which is that uh, it is called as stop, don't eat, or uh, okay, here actually some of these Indian languages versus English also, the syntax and semantics is also different. Okay, if somebody knows, in Indian languages, um, I have one sentence in Hindi which is called as "Ruko mat khao." Okay, so if somebody is a fat fellow and somebody is a thin fellow, the same sentence but with the pause or the punctuation can have a different meaning. Okay, so for the thin fellow, I will say that "Ruko mat khao." Ruko mat is don't stop, and khao is eat. Okay. Similarly, for a fat fellow, I may say "Ruko mat khao." That is stop, don't eat. Okay, so that way, in the Indian languages, the way we express is very interesting. The order which is required in English is no, so much order restrictions are not there in our Indian languages. Okay, so that the syntax in the semantics is interconnected. This is the idea I'm trying to convey here, that example. Okay, so how we interpret or read sentences in the logic is related to the semantics. Okay, and that for every sentence of the logic, we are trying to assign a meaning with that. Okay, for example, there is one example given here. All lecturers are 7 foot tall. Okay, so if you look at this sentence, is it a valid sentence? Yes, it is a valid sentence, because from the syntax point of view, there is no mistake in this sentence. Okay, that is now, so just like grammatically it is correct. Okay, all lecturers are 7 foot tall. Nothing wrong with the grammar and all that in the sentence. But factually, there is a problem, because if you go into the meaning and try to understand that, which means that there are lecturers, and every lecturer has to be 7 foot tall. The height of the lecturers, all the lecturers, is that they have to be 7 feet tall. Okay, which if we go into the meaning of it, that, and we know from our real life expectation that there is no such kind of thing. Nobody is 7 foot tall, much less lecturers who are 7 foot tall. Okay, so when you go into the meaning and you understand that there is that this sentence is actually, in terms of the meaning, it is false. All right, so the point to explain with this example is that what is meant by the syntax and what is meant by the semantics. Okay, semantics is related to meaning. Okay, meaning is that when somebody is trying to interpret that knowledge, when they are interpreting and applying that interpretation, okay, and then of course trying to relate it with other facts. Okay, so that is when that semantics is coming in. Okay, otherwise syntax means it is just like that, your the language rules are there, you apply the language rules, and you will be able to go forward with that. Okay, I hope this is all these matters are interesting. I'm trying to explain it in the kind of conventional language. Okay, so we have completed this. Next, let's talk about the propositional logic. Okay, so propositions is the main thing in this propositional logic. Okay, so suppose I want to make an assertion, like in that it is wet. It has rained and it is wet. Okay, so I want to make assertion. It is wet. Okay, and then we are having the the proposition being related to by the connectives. Connectives means that as you can see here that some 4, 5, 6 so a few symbols are shown. Okay, it is and, or, not, implies, double implies, like that. Connectives are there. Okay, so if and only if, rather the rightmost one with the double arrow, that is called as if and only if. Okay, implies is only one side. If, then, that is implies. Okay, so that's why that arrow is going only one side. If and only if is that it is going both the ways. Okay, so these are the different types of the connectives and the symbols which are there for that. Okay, so again, like language, now we are learning the logical language. Okay, then you are having brackets. Brackets is there to assign a context. Okay, so that is whether some statement which is no is either true or it is false. Okay, so like that we are having these statements which is there. Then you are having the semantics. Okay, so semantics is related to the meaning. Okay, I have explained previously in the previous slide about the meaning. Okay, so that is meaning means that and there are other aspects of that semantics, that the semantics which is derived from the logical representation. Okay, so if that is P and Q is true if and only if P is true and Q is true. Okay, so in which case we have to work out with a truth table, wherein we will take that what is the truth value for P, what is the truth value for Q, and then we try to work out that what is the value, the truth value for P implies Q. Okay, so how will that work out? So there are many truth tables, and we can look at those truth tables and work out these semantics. Now, the next step is that we have what is called as predicate logic. So in predicate logic, we are combining the, so while propositional logic is with atoms, okay, and there is no propositional connectives, and we don't have some kind of a structure that say like that today is wet or John likes apples, something like that structure we don't have. Okay, but in the predicate we are allowed to formulate some kind of a context. Okay, so that we can talk about some object. Okay, so is wet property, let us say. Okay, is wet property can apply to a day. So day means like say today, and you can have that, you can use and express relationships between some entities. Okay, so likes relationship is there, and we want to say that John likes apples. So we will put that the arguments, that is John and apples, and that we will give it to the predicate logic operation, that is likes. So that if it is being processed, it will generate that John likes apples. Okay, and then at the basic level, every predicate has to instantiate to either something being true or false. Okay, so basically, in summary, in a predicate logic, each atom is going to be a predicate, and and this is the way it goes in either first order logic, even higher order logics. It will go like that. So we'll take up these things one by one. Okay. I think I have completed roughly about 1 hour of speaking. Is that right? So if what may be the correct time to have a break, please let me know so that I will give a pause and join back again. Okay. All right, let me just continue then. So next thing which we are taking up, that is called as the first order logic. Now, first order logic will be more expressive than the propositional logic, and mostly a lot of representations which we use will be having this first order logic. And here a new thing is there, that we have variables, and you also have constants. Okay, so constant means that it is not given the framework of that set of statements, there is not going to change in the value, and it will be there throughout that reasoning. Okay, so constants, say like the some names of the entities, John, Apple, something like that, that is treated as a constant here. Okay. Then you are having the predicates, which are the properties and the relationship which is there. So relationship is that likes. Okay. So likes John apples. Okay. So the predicate and the property is liking, and those participating in that is John and the apples as the objects. Okay. Of course, a lot of research done on whether the object is passive or something like that. Those kind of things are there, but it is useful for this purpose only. Then you are having the functions which will be transforming the objects. Okay. So I can say likes John, and then I may not give the name exactly. I will say that it is, we have to apply fruit of operator, and he is to apply that with the of a tree. So that's why I will write like likes John, comma, fruit of apple underscore tree. Okay, then variables I have anyway explained that variables can represent any object. So if whoever say like whoever is there, that variable can be represented by X. So it can be John, Mary, it can be um, Ram, it can be Sita. So like that, whoever is that, that is X. X maybe is having the property to like the apple. Okay, so as a variable, I may write and say that likes X comma apples. Okay, and in the logic, one more thing which is there, it is called as a quantifier. Okay, so this quantifier will be able to qualify the values of the variables. So if it is a universal quantifier, meaning that it is true for all the objects in the system. Okay, so that is being called as for all X, comma, likes X, comma, apples. Okay, this is a universal quantifier. Okay, so that is all those people who are there, they are supposed to be liking apples. Okay, but as we know, sometimes there are always some exceptions, or there is those kind of things is, so we can formulate the approach in a slightly different way, in which we call it as a existential quantifier. Okay, means that there is something which is existing. Okay, so for example, there will be, if you consider the apple like those who like apples, okay, we are confident that given some big city like Hyderabad, we will be able to find at least one person who is liking apples. So it is very important for everyone to understand and appreciate this slide before we go forward. looks like people are following this. So let me go on to the next slide and show some example. First order logic sentence is there. Okay. So every rose has a thorn. How will we represent this sentence? I mean, okay, in the first order logic. So every rose, okay. So there is, we have to say that if X is a rose, and if X is a rose, so that then we are writing as the rose X. We are writing that is a rose X, and for every rose X. So that's why we are keeping that scope in the brackets for all X, okay, and then within that for all X we are keeping the statements, okay, and here we are saying that there is a thorn in every rose, okay. So then what we have to see is that, say suppose the name of the thorn that we are using a variable X, X is already there, we are using another variable Y. So for that variable Y, we are saying that that variable Y is having a thorn, okay. So it is a property for X, so that is called as has property. So that has X comma Y property, and what is that property? It is having that thorn. So this is written as there is, so that is has X comma Y and it's a thorn, okay. So every rose, and now what is X? X has to be a rose, all right. So if it is a rose, then only this property is being applied, and so that's why the implication is there, which is capturing that, okay, that there exists a Y, and as it is a rose, it is having a thorn. Okay, so this is how this logical statement has been stated. Okay, that every rose has a thorn, in which we are saying that for all X, and for all X which is a rose, okay, so that is saying that for all X which is a rose, there is a thorn which is there with X. So this is how we are representing this statement. Some more examples. So on Mondays and Wednesdays, I go to John's house for dinner. Okay. So how do we represent this? So we have to represent this by saying that. So what is it? Mondays as well as Wednesdays. Okay. So whether it is a Monday or it is a Wednesday, there is going to be dinner at John's house. Okay. So in this first order logic sentence, we are writing in this form that for all X, okay, so whatever that X may be, and then you are going to check that and get the assertion that is Monday. Okay, so is Monday is if it is true, okay, or is Wednesday, is it true? Okay, so then only this part of it, which is called as the, you know, if you are seeing the arrow, left hand side of the arrow, okay, so that is the assertion that that it is a Monday or it's a Wednesday, okay, so that assertion is true. So if that assertion is true, then what is it that will come up? So only if that assertion is true, it will come up that and apply eat meal me comma house of John is true. Okay, so that is that that the dinner meal which is there is at John's house, and that you are the one who is going to be eating. Okay, so eat meal for you and John, the house of John and X. Okay, so like that, or everything has to be true. So then only it is correct. So now and or those kind of things are there because sometimes and is used as a connective or is used for to indicate a choice. Okay. So whereas if you see the first half of the rule here, that Monday or Wednesday. Okay, so that's why that or is needed. Okay, so I hope this part of it is clear. Then we have what is called as a higher order logic. And this higher order logic is supposed to be more expressive than the first order logic. And here what is happening is that we are having the functions and the predicates, and they are also the objects. Okay, so for example, say like addition is a um, uh, property, and for binary, there is a binary addition. Okay, so you can describe that by the predicate. Okay, or we can have a transformation. Say for example, differentiate square. Okay, and we can quantify over the both things. So that is, for example, um, red is a 0 at 17. Okay, red may be some function or whatever it may be. So there we are saying that for all f, and I mean for all f, it is a red f is implying that in at 0 it is having value of 17. Okay, so this is somewhat more difficult for the reasoning. Higher order logics are more difficult for reasoning. And it is not stopping at that. You're having what is called as multi-valued logics, and you're having modal logics. So in multi-valued logics, that the output or conclusion may have more than the two truth values. Okay, so it may be true, false, and it may be unknown. Okay, or you may have uncertain reasoning where you use fuzzy logic or probabilities, and where this assertion of that value will be between 0 and 1. Okay, so that can be used in the multi-valued logics. There are other types of logics like temporal logic. Temporal logics are useful, which is when we are dealing with time. So time means like tense. There can be present tense, past tense, future tense, present continuous kind of a tense. So many kinds of tenses are there, which we have to express in the temporal logic. So there are inference rules also for the temporal logics, for the epistemic logics, and things like that. And the epistemic logic is basically it is about a belief or that this is there, so therefore I believe that with this amount of credibility, like that. So why is logic used? Because logic is said to be a good representation, and it is possible for us to do the representation in some kind of local processing itself. And but it is subject which is studied highly, and number of you can say schools or those kind of things, they exist to be able to solve and crack the representation issues which is there. So logic is also allowing us to do the logical reasoning, and the logical rules and formulations are anyway there. So therefore, the tools and techniques are becoming free to use. And it is the basis also for some of these programming languages like Prolog. Prolog uses the logic programs. I have explained this earlier. Another one is that add Prolog based on HOL. So this is the accusation. So that is that prologue is based on the higher order logics. Okay. Further on, then, what are the non-logical representations? Structured representations, basically. You can have production rules. You can have semantic networks. Under semantic networks, two types of networks are there. One is called as conceptual graph, abbreviated in bracket as CV, or other one is the frames, which is again some kind of a data structure with links. And the logic representations will have the restrictions, and it is going to be hard to work with. Okay, so that is the problem of the non-logical perspectives, and we don't use much of the non-logical perspectives. Okay, and this is just in line with what I am supposed to be speaking. This is called as the production rules. The next part of my talk is supposed to be on the production rules. Perhaps I may not be able to do justice to that. But let me explain that what it means a production rule. I already explained that there is a rule-based system, and in the rule-based system, there may be different actors which are there in that rule-based system, and they get a triggering when they are sent the message on the rule. So this kind of triggering of consequence of explanation action like that. So that is written as, so basically what we do is that we are taking the logic formula and reducing it into the condition and action kind of things. Okay, if condition, then action. So we are just laying down that which conditions should lead with what actions. Next point then is that about the resolution process. Now, resolution process is the logical process by which, suppose we have very large number of clauses. Okay, how do we find out that whether it is true or not? So you have what is called as multiple production rules, which may fire at once, and they may check like that and come back to us. Okay, I'm sure this type of example from your programming languages you can know, and you'll be able to talk about that. Okay. So, but basically what happens in the match resolve act cycle is that match is one of the people which is here. So they give us the agent activity, and like this, the rules conditions. Okay, rules condition is important because then otherwise you don't have anything. Okay, so that's one. Other one is that the resolutions. What is the resolution? That the resolution is that the multiple production rule may fire all at once. Okay, another is that the agent must choose the virtual rule from the set. Okay, and then we have what is called as the working memory. So working memory is like, you are making some calculation, you are having a scratch pad in front of you, and you may complete one row or column of the memory, and then you may say, okay, I need this much of cache or this much of whatever. So you are going off to some party which was there for this kind of things. Okay, so that is meaning to say that we have the rules which are getting triggered, and the information in the rules is also indicating that what should be the role or action from that condition. Okay, so and this all the information which is coming from these rules is added into the working memory, and there you are having something which is matching up these things in the working memory. Then we come to the last part, that is the knowledge may match and fire the other rules. Okay, some examples of the production rules I'm showing here. If bus stop and the bus arrives, then the action is to get onto the bus. Meaning that unless the bus, you're at the bus stop also, and that the bus has to come. Okay, only if the bus comes, then the left part, if part will be realized and becomes true. Then only you can see that is there a bus, and you can try to act on the bus. So that way. So then if you're at the bus stop and the bus arrives, then you will get onto the bus. Okay, so if on the bus and not paid, okay, and then you have some prepaid card, so then that way you will be able to pay that your bus, right? Okay, and no, when can you sit down on the bus? That it is a paid card and an empty seat, then according to those things you can put and you can sit down. So whatever it is, the conditions actions must be clearly defined as compared to those expressed in the first order logic. Once again, I'm asking the organizers, how am I doing with respect to time? If some break, etc., is required now, can we take that?
Yes, sir.
Huh? Okay.
You can have a break, sir.
Okay. Okay. So I will be connected, and but I'm stopping my speaking.
Yes.
Okay. Okay. Fine.
Dear
Please.
participants, sir will rejoin after 10 minutes. Please take a break for 10 minutes.
Fine. Thank you.
Thank you. Sir, shall we start now? Sir, can you hear me, sir?
Yes, yes, I can hear you.
Yeah,
So
you can start now, sir.
can start again.
Okay, sir.
I have continued to share my screen, but I've changed the slides. I suppose it is visible, or okay, we can.
Yes, sir, it's visible, sir.
Okay. So this is just to show that that there are different ways in which people look at the things. What I have shown you other is one other way, but as you can see, for anyone who wants to learn, this professor Pushpak Bhattacharya from IIT Bombay. He is very well known in this field of knowledge representation because he's worked with this um, natural language systems. So he's very famous for his work on the natural language, and he has made a lot of work on something which is called as WordNet. And so this slides is from his slide of, so all the basic slides also, I mean, it is a basic set of slides. Let me just show that. So this is the basic lecture which is on. So once again, we can see here that what is the predicate calculus. Okay, so some information is being represented. Okay, so like suppose you're having three people, A, B, and C. They're belonging to the Himalayan club, and every member in the club is either a mountain climber or a skier, or both. Okay, then you have some more information like A likes whatever B dislikes, and dislikes whatever B likes. Okay, so that's the thing, that notice that A is liking whatever B is disliking, and he is disliking whatever B is liking. Okay, now A is liking rain and snow, and no mountain climber likes rain. Every skier likes snow. Okay, so then we want to know that, we want to answer the question, is there a member who is a mountain climber and not a skier? Okay, how do we answer this question? So to answer this question, we are having that there are facts and there are rules. Okay, so whatever is given in this problem statement is the facts, and the rules are there for the inference. Okay, so that is how a problem like this can be solved. How do we solve this? To solve this, what we are doing is that we will denote by MC a mountain climber, and SK is going to denote a skier, and the knowledge which is given in the problem will be formulated like this, that first of all we have to assert the membership. Okay, so A is a member. Similarly, B is also a member, C is also a member. Okay, so first three things are to assert that A, B, and C are members. Okay, then we also are asserting that those who are members, they are doing either mountain climbing or they are doing skiing. Okay, so then the clause number 4, that for all x, if x is a member, in which case then the member is either a mountain climber or is a skier. Okay, next sentence is that for this member, whoever is a mountain climber, okay, the mountain climber will not like rain. Okay, whoever is a skiing member, they will like snow. Okay, so these are the other basic informations which are there. Okay, now to answer the question, which is that how do we answer the question that is there a member who is a mountain climber and is not a skier? Okay, So is it possible to find out that? So that is there. The question is there in the clause 11. Okay. So to come back to the representation, the skier likes snow, that is in like 6, and about the members, that is for all x, that is if x is liked by b, then it is disliked by a. Okay. Similarly, the opposite of that is the does not like by b, it is liked by a. Okay. So then we know that a is liking rain and a is liking snow. Okay, so then it will be quite clear that if it is B will be the opposite of that. Okay, so how do you answer the question? To get back to that, there is a process which is called as resolution refutation. Okay, so refutation is the process. So it is a bit complicated. I cannot go through that, but all the textbook materials are having that resolution refutation process. Basically, what you do is that once you have made everything into clauses, you will negate the opposite of the. I mean, the question. The question is there. The clause of the question will be negated, and you will be adding it into the set of clauses, and then you are going to try to come up with a contradiction. Okay. So if you come up with a contradiction of the negation of the question, then it means that is true. Okay. So when we are looking at knowledge representation, certain properties has to be followed, which is called as that should be a property called adequacy, okay, or completeness. So the representation should be adequate. That is, it should be able to allow us to represent whatever facts which are required to be represented. Okay, so adequacy. Then there is another property which is called as correctness. That there should not be a misrepresentations, so that the knowledge representation is correct, and there should be the efficiency. That is, it should be suitable for being able to do reasoning and complete the inferences. Okay, so that is called as the inferential efficiency, inferential adequacy, okay, representational adequacy, representational efficiency, reputational correctness, like that. Okay, and then another thing which is very important is that we should be able to acquire more knowledge also. Okay, so that is this acquisitional aspect, that we should be able to add more knowledge. Okay, so that is, there should be acquisitional adequacy, acquisitional correctness, acquisitional efficiency. Okay, so these are the aspects which is very important about the knowledge representation. All right. So the representation should be able to represent everything in the scope, expressive power, and correctness, efficiency, and the knowledge represented should be structured. So, for example, we may be able to structure it into tables, or it may be semi-structured, for example, XML, or in databases, or the knowledge can be totally unstructured. So like knowledge which is there in text. So, for example, tweets, the knowledge is not structured. Okay, so it is a plain text. So a lot of AI programs have been built in which we want to extract sentiments from the tweets. Okay, so a lot of natural language processing and all that is there to extract information and sentiments from the tweets. So if you have tables,
Can I interrupt you for a second, sir?
Yeah, please.
Yeah, I have a small doubt, sir. In industry,
Yeah,
how these concepts are used in our career perspective from student point of view. Can you just explain at the end, sir?
yeah, okay. See, thing is that these are all the theoretical aspects, but when you are going to apply it in practical aspects. So suppose you are going to build an expert system. So we have to build expert system, or nowadays it's called as recommender system. So these aspects are so you have to take up a domain, and you have to build up the knowledge base for that by using the if then rules. Okay, let me see if I have some example of that. in this perhaps okay, so for the semantic graphs etc rules and that is there. Okay, UNL kind of representations is also there. So so what happens is that we have to go into these aspects of the building the knowledge base, right? That is the most important practical thing, that if you want to um, if you want to go to practical aspect, so then these rules has to be built up into some knowledge base, and then it has to be used there. Okay.
Is there any specific tool nowadays for doing this knowledge representation, sir?
There are actually tools to build up the expert system itself.
Okay, sir.
Huh, huh.
People are nowadays using tools in industry for expert systems.
Yes, yes, yes.
Can you share any tool name or anything if you have?
We can do some. Okay, now I'm sharing my browser window. So let me just see that we can. So the building expert systems, it is being done in Prolog or things like that, you know. So for example, look at this book, Building Expert Systems in Prolog. Okay, Building Expert Systems in Prolog. No? This book is there. Okay, so if you know Prolog, people can learn the Prolog, and then, you know, using the Prolog, they can build the expert systems. Why Prolog? Because Prolog is having built-in inference engine. Okay, and backward chaining and all that is built into the Prolog. So that way, the frames and all these kind of things, if you see, and it's all built up. No, so that is one of the benefits of working with Prolog. Okay. And there are some jobs wherein people want the knowledge of Prolog. Okay. So but even otherwise, actually, we can build the expert systems with Python also. Okay, so for example, this video is there, how to build this expert system with Python. Okay, so all these things are also there. Now some GitHub and all that things are also there. No, so that rule-based systems which was there. Okay, so all these things is also there. So that is the thing. So basically what we have to do is that whatever is the information or knowledge, we have to build the rules regarding that. So basically that is the thing to answer the question. But what is more important actually is to understand the structured representation of the knowledge, which can be in the form of some graphs and the links which is there. You know? So this UNL is a universal approach to the knowledge representation. Okay, UNL representation of knowledge. Okay, so you have to study this, and it will allow us to represent these things like graph. Okay, semantic graph which is there. Okay, so that is, somebody is there, they have bought a student bought a computer in June. Okay, student bought a new computer in June. So then this sentence will be translated into this kind of a semantic graph. Okay, so that is, bought is there, relationship is with the object, that is computer, and the agent is that one who buying is the student. Okay, and then it is a tense since it's a past tense, and in June, so like that, this representation will be there. Okay, and now if some other questions has to be answered, then based on this representation, the question will have to be answered. Okay, so UNL is the important thing. Okay, then switch back to the other slide which I was having. Okay, so this part is where we stopped. That we had all the logical rules and all that statements and all that. We have to express it as the rules, the production rules. Okay, production rules is simply that it is a knowledge representation rule in which it is allowing us an inference. If A and B, then we are going to have this action part. Okay, so for example, that if I'm at the bus stop and the bus has arrived, then we are going to do the action that of getting onto the bus. Okay, so like that. So if I'm on the bus and I have not paid my ticket and I have some kind of a card which allows my payment, then I can pay with my card. Okay, and then the status is changed to paid. Status was not paid, and the status will get changed to paid. Okay. If you are on the bus and you have paid and there is an empty seat on the bus, then you can sit down there. Okay, so like this, all the actions and the conditions will have to be clearly defined, and they can be expressed in the first order logic. Okay, so for some simple things and all that, it is somewhat easy, or it is possible to define all these things. Okay, but when it becomes very large number of complex cases, then it becomes difficult to set up and define. So basically, that is been the problem really. And important thing which is there is that we have to set up the causal relationships. In real world, there is a causal relationship, meaning that there is a because of A, so B is happening. Okay, that is a causal relationship. Okay, so and those are the limitations also. Okay, suppose I want to decorate my room, I must have the paint and the wallpaper. Otherwise, I cannot decorate my room. Okay, so you also have to check the color scheme, then only you can decorate. So like this. So for example, in mathematics, set, if you add the operator monoid, then if you have a sum set, it becomes group, and then add in a group you add operator, it becomes a ring, like that. So and why graphs? Because graphs can be easily stored in a computational form, and you can impose the formalism which is there. Okay. So for example, these are two graphs in which we are saying that Jim is Arthur's brother, and Arthur is Brian's father. Jason is Brian's father, like that. So the question is, or rather, the arrow relationship is that other way around, rather. Father of Jason is Brian, father of Brian is Arthur. Okay, and so like that. So some other relationships are also shown in the other graph. So if Jason is 15, Brian is 40, and Arthur is 70. Okay, and Jim is 74. So we have been given this information. Other graph, if you have to see that to answer the question, how old is Julia? So Julia is mother of Mildred, and Mildred is a sister of Ida. Okay, so Jane is Jason's mother, and Jane's mother is Ida. Okay, so like that. So how old will be Julia? So kind of things are not so easy to answer. So how do you use is that you can apply syntax and you can say that Julia's age will be similar to Brian. Because how? Because both of them are at the same level in the graph. Okay, so like this we can apply some inference approaches. So as to represent the information, we need the logical statements, like the first order logic statements, and the relationships is required to be present in the form of graphs. And through the graphs, it is better because we can get subset and member relationships. Okay, so all these things is much better. And there are representations which is well known in literature, which is called as, say, conceptual dependence theory, which is made by Roger Schank. And you have some graphs which are there like that. So the conceptual graphs is important formalism which was developed in the AI, wherein we have a semantic network, and each graph will be representing a single proposition. So then you have some concepts, and the concepts which will be there. So say for example, a restaurant, or suppose for example some dog. Okay, these are concrete, means you can imagine that, but sometimes the entities are not concrete, they may be abstract. Okay, so we cannot visualize, say for example anger. Anger is an internal property to a person. Okay, so if that person is not expressing anger, there is no way for us to understand that that person is having anger. Okay, and then the problem with the conceptual graphs is that the edges do not have the labels. Instead, the conceptual relation nodes are there. So, but because of that, it is possible to represent the relationships between the multiple objects. So, for example, suppose you have three of them, Jack, James, and John, and we are having the relationship of brother with them. So from this, we should know and understand that. But the problem here will be that how do we infer that James and John are brothers, or Jack and James are brothers? I'm not too clear with that. Because one other type of representation is called as a frame representation, and here the semantic networks will be where the nodes are having the structure. So basically here it's a slot and filler kind of a representation. Frames is a slot and filler type of representation, where you have the frame will have a number of slots. Why it is called as a frame is because there are some slots which are predefined. So if it's a person, age, height, and other relationship kind of things will be predefined and kept. And either if you have information, you will fill up that slot. If you don't have that, it may be kept empty also. Now, when an agent is facing some new situation, the advantage of frames is that from another frame, which is a parental frame or something like that, you might be able to fill in the slots. Okay? So inheritance and things like that is useful in the frames, and you can fill up that information. Okay, and if you fill up that information, you may trigger some other frames also. So this is the the frame in representation and its inference mechanisms. So inheritance of properties between the frames. Okay, that's a very important thing. And this is also similar to the inheritance kind of concept which is there in the object-oriented programming. So for this reason, frames are considered to be somewhat easier to use and represent. Okay? And like I showed you Prolog, which is an AI language. Another language is there, which is like Lisp. And in Lisp language, these frames kind of things is very commonly used, very popular, let us say. So you can see, for example, a frame representation here. So here what we are seeing is that suppose we want to represent a lecture, and we want to represent the person giving the lecture. So if you look at this, the frame for lecture is being represented with the slots. All these small boxes which you see, these are the slots. Okay. So a lecture, what is a lecture? Lecture is a special form of a meeting. Okay. What is the context? Context means there will be a lot of students. Okay. So for every lecture, we have to say that whether it is related to a course. So here say course is that the course is given is a operating systems course. Okay, what is the level of the course? Is it easy or difficult? So difficult is there. Okay, then if it is difficult, any lecture which is difficult, then it is expected that the students will be paying attention. Okay, other facts may be there about the lecture, that who is the lecturer for that lecture and in which room that lecture may be taking place. So this is a kind of a basic level data information which can be gathered and kept. Regarding the lecturer, the name of the lecturer will have to be given. So say some Professor Jones, and whether it is whether that lecturer is, you know, a liberal one or it is a strict one. So a strict one means that, you know, you cannot have mobile phone and things like that, and then you have to pay attention in the class and things like that. So this way we are able to represent that the lecture information and the lecturer information. Okay, so by all means, this is not the only way of representation. There are so many other types of representation and things like that, but this is just to show an example that how we can represent information in the frame representation. Other properties are good in the frames. That is, in the frames you have the slots, and the slot can contain the information for choosing the frame in a situation. Okay, so that is in the context. What is the context in which this frame will become active? Okay, what are the relationships between this frame and other frames? Okay, and what are the procedures to carry out after the various slots are filled? Okay, so this procedural attachment is the very important aspect of the frames kind of concept, which was not there in the conceptual graphs. Okay, so the default information to use where the inputs are missing, that is also important aspect which is came up in the frames concept. And it allowed the keeping the blank slots like that, and how it is related to the other frames, you know, so you'll get a hierarchy. Okay, and the information in the frames can also be expressed in the first order logic. So not just logic representation, but we want that production rules is there, semantic networks is there. So that's why in AI, these are all playing an important role. But all of them can be reduced into the first order logic. Why is logic important? Because the logic representation is allowing us, it is well-defined representation. It will allow us to have the inferences also, and reasoning, you know. So the reasoning is a very big thing regarding the storage of information. Okay, so with that, I end this slideshow. Okay. So now some basic concepts are there. To show you further, I will try to show something which is called as the ontology. Mm. So anyway, there are many such things: representation, reasoning, propositional logic, syntax, you know. So if you want to study with what all it means, you know, so these kind of things, very short kind of thing is there. Here, one important thing I wanted to show is that when you're having logic, how do you reason? Okay, so this kind of things is shown as the reasoning approach. Okay? And yeah, one more thing is very important. Let me show you that. This is slightly advanced, but this is called as the Handbook of Knowledge Representation. Okay, so you can download this book. It's a free PDF or some, because I found it, it is a free PDF, I think so. Or if there is any difficulty, you can. So the reason to show this is that what all the topics will be there for knowledge representation, serious topics, etc. It is given here. Chapter wise description is there of the topics in this. No? And nowadays, a lot of these SAT solvers are being used in the logic. So general methods in the knowledge representation with the logic, propositional logic, and all such kind of things there. One other thing which we have to know is that the description logics and constraints which is there, conceptual graphs is there. Another new important thing is which is called a non-monotonic reasoning. So in the non-monotonic reasoning, what happens is that suppose I have given the statements A, B, and C. Later on, I remove the statement B. Okay, so which means that the logic which I am trying to reason, it will become totally collapsed because B is removed. Okay, so that's why this is non-monotonic, meaning that the way these inferences is there, it cannot be only in one direction. Sometimes it will go back, and then we have to do that, redo that. Okay. So that is the thing which I wanted to show. Further, okay. Now this is another set of slides. So how do you do reasoning? So you are having two types of reasoning. Here it is showing deductive reasoning, which is called as a forward chaining production rule systems. Okay, so what it means is that if, then, else. Okay, so when you go on chaining, if, then, else, if, then, else, if, then, else, and you are having the rules, then you will be coming up with a series of reasoning chains. So this is one of the things. Now, another approach for reasoning, which is called as abductive or uncertain reasoning. So abduction is that even if you don't have that if, then, else, just if you get one part, maybe you will say that okay, it has to be this or it has to be that, because of previous knowledge or something like that. Or there are other problems which is there that the knowledge is not certain. Okay, so how do you reason in the absence of full certain knowledge? So Bayesian reasoning is a probabilistic kind of reasoning. Then you are having fuzzy reasoning, Dempster-Shafer theory reasoning, all these kind of different types of different reasoning are there, which is in case of uncertain. Okay, so many of these things I have already covered. This is giving you better idea of the forward chaining, that is the production system kind of thing. And so here condition 1, condition 2, condition n is implying some kind of action 1, action 2, action m. Okay, so left hand side and right hand side is there in the production systems. Left hand side is what? It's a condition which must hold before the rule can be applied. Okay? Right hand side is a condition, the action which has to be performed, or the conclusion which is to be drawn when the rule is applied. Okay? So all expert systems are built up of this kind of forward chaining of production rules. So what is there in a production system? The basic concepts are that we are having rules. Rules is unordered set of user-defined if-then rules. And then you have what is called a working memory, where a set of facts consisting of the positive literals which is defining what is known to be true about this world is given. Okay. Then you have a inference engine, which is allowing us to produce the inferences and add or delete the instances into the working memory. Okay, how do you do? So it is like this. It is based upon a process which is called as matching. So what you do is that you start with one of the rules, and then you will try to find out the preconditions and try to find out that which all is the kind of things which is there.